Okay, everybody, the next session is going to start. Thank you for joining. The speaker is going to be Steve Poitras, Chief Architect at devrev.ai, here to speak about scaling SaaS applications with MongoDB.
How's it going, man? Thank you. All right, perfect. Well, first off, just want to say thank you guys for coming here. If you guys do want to get close or ask questions, definitely feel free to come forward. One of the things before I get started here, especially kind of in settings like this, is feel free to ask questions. If you have questions, if you want additional context, ask. Especially with the amount of people that we have, let's make this very conversational. Last thing I want is to just sit up here and talk to myself. So let's definitely ask some questions. Now I'm going to start with a quote. The best designs are those that grow with time, anticipating the needs of a future we can only begin to imagine. Now, this is a very important thing, right? Especially when we start thinking about the era of AI that realistically is just at its inception. We don't know what the future holds. But the thing is, as architects, as developers, we have to ensure that we design things correctly so that we don't shoot ourselves in the foot or don't haphazard ourselves in the future. And that's a key thing. Now, one of the things, obviously, looking at history tells us a little bit about evolution. A key guiding principle that we've had is the fact that, or the idea that convergence enables efficiency, autonomy or automation delivers it. And here's some examples of it, right? So if we look back to the origination of the iPhone, what did it do? It converged multiple devices into a single device as apps. And just think about all the efficiency that we gained through that process. You can now share a photo immediately via text. You can now call someone. You can FaceTime someone. You can create things on this single device. And through that convergence, we've gained so much efficiency. At our previous company, Nutanix, this was where we saw the benefit of Flash was only when it was co-located next to the compute or things that were processing it. So by converging these two things together, we gained efficiency. If you had to access an NVMe all the way over the network, you're not getting the true power of that device. So through convergence, there's efficiency. Now, the one thing is, if you take the iPhone as an example, you could tape everything together. An MP3 player, a cell phone, a video recorder. You could tape all those things together and retrofit it and make it look or have the same functionality. But the problem with that is you don't get all the efficiencies that are gained through the native integrations. And this is a key thing when we look at convergence, is there's a difference between retrofitting existing things versus natively converging them together. And this is an important thing because when you look at companies today, you have engineering teams, you have PM teams that are building software. They have tools like Jira, GitHub, what be it. You have your support team, ticketing systems, intercom, what. You have your operations teams, PagerDuty, Datadog, what be it. And then you have your growth teams, so your sales and marketing teams that have different systems. And this is the thing that we realized is as you see these things, you start to see very apparent silos start to form. Not only from an organizational perspective, but also from a data point of view as well. And some of the problems that this entails is knowledge silos. If you asked one person what the ROI of an effort was, you'd have to go talk to finance, you'd have to talk to engineering, you'd have to talk to marketing, you'd have to talk to support because all of those aspects come into the cost. So you don't have one true picture of what the actual impact of things is today, as well as a ton of miscoordination and inefficiency. And as businesses, we like to just deal with it. And this is one of the things that DevRev is, at our previous company, we grew it from when I joined 40 people to 9,000 people. And we saw this inefficiency, we felt the pain, but people were just, I don't know, understandably, they were okay with it. And that's one of the things is we were not okay with this. And especially if you look at kind of the trends in the market today, people are growing impatient. I don't want things later, I want things right now. I don't want to ask someone for something, I want things to be self-service. I don't want a generic experience, I want something that is custom tailored to me. And I don't want to search for something. I want to converse or I want to get answers. So the world's changing. And that leads us to the first piece. AI eats the world. If you think about things, there's a we're at kind of an inflection point. There's so much change which is underway, and we really don't know what the future holds. But as an example, 3 things. That photo, AI generated. The title of this session, or that quote, was actually AI generated. And I talked to an AI bot to actually help me program. And so this is a key thing is, change is not just, potential. We're not talking about Skynet, but the thing is, we're really out a fundamental change, or there's going to be a fundamental shift in the way we work, the way we do business, which also leads to differences in the expectations of our customers. If you just look at this chart here, this just shows kind of the step improvements that we've seen in some of these language models. And this is just the inflection point, right? And I would assume, it's not going to grow exponentially forever. However, what will occur, we're just at the inflection point. You can see from the early 2000s, it was very apparent what was computer-driven. However, in 2020, people can't tell the difference. And this is an important thing because when we think about the way we work, how we interact with one another, what we have to do personally versus shifting to a system, the fact that a system can actually interact with us, help us, augment us, is a very core thing. But one of the key things here is, AI without context or data has very limited value, right? And this is a key thing because let's just say as a developer, if I want to ask it a question but it has 0 context about my source code or about what I'm trying to do, its answer will be very boilerplate, just no different than what are the, some of the code snippets that I can get today. However, if it has understanding of my code base, if it has true understanding of what I'm trying to build, if it has understanding of other things that other people are doing, it can give me a much more relevant answer. And that's a very, very key thing. Which kind of leads to us, our whole idea was looking at those various facets of the business, if we can pull and converge all that data together into one platform that everyone worked on cohesively, use that to drive our AI models, the results, as far as our hypothesis, could be much better. And that's kind of one of our things. Now, this is actually not a fake quote. This is a very good quote from JFK, but change is the law of life, and those who look only to the past or present are certain to miss the future. And this is a key thing because if we look and bias ourselves so much with how we've done things in the past, and if we lose sight of what the future holds, it really inhibits our designs. And this is a key thing when it comes to talking about architecture or designing an architecture, is we really have to not think about how things have been done in the past. Drop all that garbage, drop all that bias, and look at things with a fresh point of view. All right, so now when it comes to SaaS, a few of the core tenets, obviously SaaS stands for software as a service. Basically, it doesn't have to be just about software. It can be internal service delivery, any of those things. It's a mentality. And some of the core things that I think about, and obviously the acronym makes sense here, is it needs to be scalable, right? Especially when we start thinking about the age of AI, we have tons and tons of data. So how far, how fast, how efficiently can I scale things? And it's not just about scaling resources, but it's also about scaling your efficiencies, your automations, your resources, your people. Your people are going to be the most limiting resource here. From a resource point of view, how do you do horizontal versus vertical scaling? Can you scale things independently? These are all key considerations. Agility, this is one of the other, probably the most important thing. Given the rate of innovation and the rate of change that we're seeing with all of the various models coming into play, all the new technologies, all the new demands that people have, how can you actually keep pace with that? And one of the keys here is, you really can't. You can try, but unless you proactively engineer for this, it's very difficult. So, doing things like leveraging abstractions that allow you to, incrementally add new and bolt new things on without having to re-platform things. Leveraging automations. You can't be agile if you're not automated. And we'll talk about a few of these things here in a second. Okay, here we go. All right, so the next thing, available. Now, when we think about the expectations of people, people want things to be on demand. They want it to be there all the time. If I go to ChatGPT and ask it a question and it's unavailable, there's kind of some malintent there. I expect it to be available. And especially when we start talking about business critical processes, things need to be up and available. But that doesn't mean everything has to be available. There's okay scenarios where things can be down. And that's one of the things, is you have to engineer. Everything can't be HA. Everything can't be 5 nines. When you're designing kind of a solution, what actually do you need? What requirements do you have? And there's a difference between real availability and perceived availability. As an example, let's just say you have a backend service or an API that you want 5 nines availability with. Now, the backend can become unavailable, but if you have the ability to actually serve cached reads, your read availability is still there, even though the backend is unavailable. And so there's ways to actually, differentiate between perceived availability as well as real availability. And the last thing, I think this is one thing that is I'm very passionate about, is security. Now, a lot of times, let's just say, here's a question: how many of you thought about security during an initial design of a solution or a project that you're working on? Okay, all right, so this is good. This makes me very proud. So when I was growing up, I got into phreaking, which is telephone hacking, and then got into computers. So security, privacy has always been a very, very important thing to me. But a lot of times it's an afterthought for businesses, right? When we think about the code that we're writing or the service that we're creating, authorization, our previous company, we didn't look at authorization, not even RBAC, until 7 years down the line. But that's the thing, is when you try to retrofit or when you try to bolt on, it's near impossible. And so that's a key thing, is think about security, think about multi-tenancy from the beginning. All right, here we go. All right, now, when I think about kind of the challenges that we had, they really kind of boil down to 2 things. So as a company, we are 4 years old. We started greenfield. We had 0 bias. And if I kind of boil it down to 2 core things that were very, very quintessential to us, it really comes down to data, number 1, and agility, right? So we have to deal with massive amounts of data, but we also have to build a platform and design a platform that enables us to actually innovate or keep pace with the rate of change. So going into kind of the data challenge, what are some of the challenges that we had? How do we design for data scale and distribution, right? And so when we think about data scale, if we're aggregating data across all aspects of the business, your ticketing, your engineering, your source code, your chat interactions, your deflections, your knowledge base, all the events from all your services, there is a data problem, right? And the quantity of data becomes very, very difficult to scale. The other piece is the distribution. So it's not necessarily only distribution to your consumer, but it's also how do you consume from that producer as well. And doing that efficiently is very important. Performance. Now, if you're interacting with, let's just say, a chatbot or ChatGPT, you expect a chat-like experience. If it takes 500 milliseconds, a second, 2 seconds, 3 seconds, 5 seconds to actually generate a response, that experience is very, very poor. So how do you actually engineer to get things low latency, but still maintain and scale a massive amount of data? It's a very interesting challenge. Multi-tenancy obviously is a very important thing as well. If you want to do anything efficiently or cost effectively, you can't stamp units for every single one of your customers. Number 1, it doesn't scale. Number 2, it's very inefficient from a cost point of view. So how do you actually design multi-tenancy into your platform? The other piece is specialization. Data has gravity, right? So if I'm producing, let's just say, we produce multiple terabytes of data every single day. Now, if I have to migrate that across the globe, I can't do that efficiently. And if I have to migrate data from one system to another system just for vector search and another system just for semantic search, you start to see that it doesn't scale, right? There's too much data, there's too much, to move. It just doesn't work. And so that's one of the things, is when we thought about, kind of our core data platform, we needed something, 1, that was scalable. We needed something, 2, that was flexible, 3, that was performant. And that's really why we, went with MongoDB, because it gave us the flexible document structure. As developers, we don't have to learn something new. We speak JSON. A SaaS API speaks JSON. JSON to BSON, it's the same thing for the most part. Obviously, it's a little different, but it's very similar. It's also very scalable and efficient. So we need something that, when we started, there was 0 customers. Now we go through, right around, I would say, 1 billion to 1.5 billion requests every single month. So we've started to see a massive amount of scale, and we need something that can keep pace with that. Native integrations, obviously, is very important as well. Coming down to the data gravity perspective, if I have something here, and I need to move it all the way over here, and then over here, then over here, then over here, then back here, just looking at the network egress costs, that's very, cost ineffective, let alone, you can't keep pace with the rate of change. And so that was a key problem. The other piece was, if you think about security and multi-tenancy from your initial design, building multi-tenancy into your document structure gives you tons of flexibility. So when we designed our original object model and schema, we essentially built in a unique key into every document that is enforced that allows us to partition and build in tenancy. So we don't have to retrofit things. Things are natively built into the data. And this makes things nice because when we access things, we don't have to post-process or post-filter data. We can do that ad hoc. Now, one of the other pieces here is if we look at kind of our model, we have our consumers, so developers, we have integrated systems or event sources, we have our application, and then via a plethora of interfaces, whether it's an API, webhook, or WebSocket, people interface with our edge. And one of the things that we quickly realized is if we had to deploy things local to every user, it becomes very, very difficult. And I'll get more into that in a second. Now from there, everything goes in through an Istio ingress gateway to our gateway services. We're fully cloud native. Everything is built on Kubernetes. And one of the most important things with this is everything is automated and driven through code. And one of the things that that's enabled us to do is we can scale out very rapidly. We had an issue, I think, about a month ago where I literally just killed all of our Kubernetes pods for a particular service. But guess what? They're available. That's what they're built to do. And it gave us tons of flexibility and tons of efficiency. Obviously, you can see MongoDB Atlas is there. We leverage change streams into a Kafka CDC, which is then consumed and then fans out events to various services. Another key thing to mention here is, when we think about AI, LLMs, models, vector databases are very, very critical here, right? And so, how do you have a platform that you can leverage for primary storage, embeddings, vectors, all these things? That's a very, very critical decision. One of the other important pieces here is you'll see models and LLMs are abstracted through our AI services. So is anyone familiar with LangChain or Hugging Face? Okay, so this is an important thing, right? Models change. There's going to be tons of models in the future. How do you add those very, very efficiently? And so that's where things like those abstraction layers can actually enable you to do that. Now, this actually is kind of one of the reasons why Kafka came to be, is if you looked at what LinkedIn was doing, they had all these various services that were constantly coming up. Now, doing these point-to-point interfaces or integrations just didn't scale. So that's why they created Kafka, and then I can integrate with Kafka, and then I integrate here with Kafka. I have one interface that I integrate with. I don't have to do all those point-to-point integrations, so it gives you that flexibility and scale. But one of the problems is, when we started, we had a single data center location. We have customers all over the world. How do we actually provide a low latency experience? And the main way that we did this is through leveraging edge computing. So we are very, very heavy users of Fastly CDN, which allows us to run compute as well as serve content local to where our customers or callers actually are. And this is a key thing because it's very inefficient, especially given that we're a smaller company and don't have all the resources of larger companies. We can't build out 25 or 50 or 60 data center locations or POPs, but take advantage of the scale and leverage that scale through an edge provider. So one of the key things is obviously forward deploy things to the edge. One of the other aspects with that is optimize data movement. So when you think about storage, storage has a concept of data locality. So I can move compute to the storage or I can move storage to the compute. And this is a key thing when we start talking about all of this data. If we have tons and tons of data, we can actually do coalescing, we can do pre-processing before we actually ship that over the wire. And so doing that efficiently is very important. one of the third pieces there that is very, very exciting is, who's here has heard of WebAssembly? Okay, all right, so a few. So WebAssembly actually is a very, very interesting thing. Has anyone used Figma? Okay, so a few people. Now, one of the reasons why Figma runs so smoothly is actually because it's built on top of WebAssembly. And what WebAssembly allows you to do is compile Go code, JavaScript code, Rust code, into a binary executable that can run on a modern browser, or it can also run on the Fastly Edge. And so we're actually extensive users of WebAssembly, not only on our client, but also in the edge computing side of things. But it essentially allows you to do some very interesting things because you're not running interpreted code. You're running binary code, which runs, in some cases, more efficiently than some backend code. And so we've seen extreme benefits by leveraging WebAssembly. All right, so this piece here. Now, one of the interesting things is if we think about forward deploying things, pushing things closer to the consumer, we want to get content, we want to get computation, we want to get responsiveness as close to the client as possible. And so there's two things that we're really looking to do here. One is if you looked at the previous model, it's your traditional model. You have your client, you have your edge, which basically is just doing CDN routing logic, and then you have your origin, which has gateways, it has all your backend services. The problem with that is it's very backend heavy. And so basically our whole idea is, can we invert that stack? So what we're looking to do is, can we put an edge gateway out there? Can we take a subset of that functionality and forward deploy it, compile it via WASM on the edge compute? Same thing with our core services. Same thing with our AI services, pushing that as close to the customer as possible, or even running it in the customer's browser. So this will enable us to do a lot of very efficient things with low latency. And latency is important, right? Because we want things to be fast, we need responsiveness, and the only way to do that is by having it local. As an example, if you take a round trip time, let's just say, who knows the round trip time, let's just say from Bangalore to Virginia, approximately. All right, so I would say it all depends, but I would say you're looking anywhere from 200 milliseconds to 400 milliseconds minimum. That actually, in terms of compute time, is actually a ton of time, especially when you do things serially. And so if you have one thing that has a round trip and then a round trip and a round trip and back and forth, it becomes very inefficient. And so you start to get a very unscalable scenario. So if we can push that local where I'm operating next to something that is 5 milliseconds round trip, that's much more efficient, much more effective. The other piece there is we're extensively working with MongoDB on the concept of MongoDB Edge. So have you guys heard of MongoDB Edge? All right, so it's actually an interesting thing because it allows us to forward deploy basically slimmed down instances or replicas on our browser or on the edge and then synchronize the data between them. And this is an interesting thing because rather than having everything come back to the origin, we can actually push that out to the edge, do those updates there, coalesce those updates, and then send a much smaller subset back to us. And so that's a key thing when it comes to scalability. Now, in terms of vector databases is a very important thing. Is anyone using vector DBs today? Okay, cool, awesome. Yeah, so on the vector database side, how are you guys leveraging vector databases today? What use cases? Oh, what use cases are you guys using the vector databases for? Okay, very nice, very nice. Awesome. Yeah, and so, one of the things on the vector databases is, it's early days for them. But if you look at kind of the AI structure with RAG, you have embeddings, embeddings to vectors. But one of the problems with vectors and vector databases is the concept of multi-tenancy. And so we have one platform where we built multi-tenancy into the document. We have a single vector database that has documents and vectors that are relevant to subsets of tenants. And so one of the key problems there is how do you actually ensure that when you do an embedding and get a lookup to a vector, that the results for that are actually relevant to your tenant that you have in question. And so this is one of the things and the challenges that we've been facing, and we've been doing some innovation there to figure out how can we actually ensure that from a vector database perspective, that we're getting results relevant back to the actual tenant in question. And this is key because if I, let's just say, do a lookup, 0 of those results could be relevant to my tenant. So then I have to do another lookup, and it becomes very inefficient there. Now, one of the other things is on the cache lookups piece. If we can actually store or cache results that we've done through this RAG, forward deployed on our edge, and return results directly from there, not only does it minimize the amount of load we actually have in our backend, but it also provides for a much better experience. And so that's where, when it comes to these embeddings or RAG, if we can push and cache those results local to the client, and then assuming subsequent clients are there having similar access or similar questions, number one, we can minimize our workload, but also we can provide much more efficient experience. Now, the second and last piece here is agility. Obviously, rate of innovation is tough. Privacy is very difficult. And then, it's the Wild West, so there's a lot of risk and dependence. And so how do you mitigate these 3 things? And so one of the keys here is, when we were getting started, we obviously have the benefit of being a greenfield. Not everyone has the benefit of, writing everything from scratch. But we were big proponents on automation and code generation. And so one of the things that we wrote was a central schema definition framework, which we called Archetype. Archetype was a YAML-based markup language that essentially we use to generate all of our document schema definitions, all of our proto definitions, gRPC definitions, our API specs. Everything is generated from this single file. And the nice thing with that is one, kind of coming back to the multi-tenancy piece, this is enforced. So that tenant key is embedded. It cannot be removed. You have to have that tenant key. And this automation enforces that. It also ensures consistency. So when it comes to performance, I see this all the time. People name attributes a little bit differently, right? And so your indexes are all messed up because one thing is different than the other thing. But the thing is, here we get consistency because everything is centrally driven. And so that's something that has allowed us to scale. And plus, automation is important. So all the code generation, we want to focus on innovation, not writing boilerplate code. CI/CD and infrastructure as code, obviously very important, so we're huge proponents. Besides the pricing on Circle CI, it's been great, but also huge leveragers of Terraform and Argo CD. Another piece here, especially when it comes to microservices, is semantic API contracts. So as long as the API contract and APIs stay the same between all your microservices, you don't have to worry about the innovation of each one of those microservices independently. The last piece there is model abstraction via technologies or platforms like LangChain or Hugging Face. You don't know what model is going to be out there in the future, but if you have an abstraction platform that enables you to plug and play certain models in the future, or will help route your request to the correct model, this gives you a lot of benefit because you don't have to create all these point-to-point interfaces. All right, so TLDR here. One, use abstractions, leverage API contracts between services, model abstractions into your code and into your services, automate everything. Personally, I'm lazy, so I like to write something once and then never have to write it again. If you automate things and if you define the things as code, not only do you get auditability, not only do you get consistency as well as code reviews, but also you get efficiency and scale because you don't have to do boilerplate generic, kind of work suck, as I call it, consistently. So we use this for definitions, transforms, configurations, deployments. Basically everything is all done as code. And the third piece here, and this is one of the most important pieces, is don't fight physics. Data has gravity, data has weight. It's not easy to move a ton of data all over the world and ping pong it all over the place. So figure out where you can actually optimize the data placement or data movement. In some cases, it may make sense to move the data. In other cases, it may make sense to move the compute and then pre-process that data and then send that pre-processed data back. So embrace Edge and WebAssembly. WebAssembly is going to introduce a ton of interesting things, especially when it comes to scalability for AI. Because I can run stuff locally on the device or on the consumer, I don't have to go over the network every single time. So it has a lot of very interesting things. And then, yeah, that's it. Cool. Any questions or? Oh, yeah.
I can also come to you with this microphone. Hold on.
So you mentioned that you use vector database. So what are the main challenges that you face while scaling, like with vector databases? Because it's usually hard to scale vector databases.
Yeah, I mean, so scaling obviously is an important thing. Accuracy is an important thing. I mentioned and kind of referred to this, but the multi-tenancy aspect is important as well, because if the tenancy is not built in or it's inefficient, that requires me to do multiple lookups to that vector database. And so essentially, I'm artificially increasing load just due to the fact that the responses or results that I'm getting aren't relevant. So yeah, I would say those three key things. Oh, yeah, so on the Mongo perspective? Yeah, so there's a few things. So one, initially we started out as a replica set, which was a poor design decision, which we have realized. So that's all migrated to a sharding model. Because one of the key things, right, is if you look at sunk resources, if we have 3 nodes, 1 primary, 2 replicas, but everything's going to the primary besides some secondary base reads, that doesn't really scale, right? Because I'm not leveraging the full power of all of those nodes concurrently. Versus if you look at the sharding model, I can distribute workload across those. Now, one of the other things when it comes to the sharding model is we have almost a perfect scenario where for a shard key, we have tenant, we have type. And so that way it allows us to kind of uniformly distribute across those shards. So that's one of the things that has been migrated. And then the other piece is on failure recovery. So everything is Kubernetes based, right? So it all has built-in HA. We leverage an Istio and Envoy service mesh. So as nodes are constantly coming up and down, it doesn't matter. And I think this is a key design decision because historically we would design for RPO, RTO, and what sort of failures we wanted to handle. So do you want rack availability? Do you want row availability? Do you want data center availability, AZ availability, region availability? But not everything needs to be highly available all the time. And so for us, I mean, obviously, we've decided that each, basically what I call devrev pop, is only regional. So we will handle failures, an AZ failure, multi-AZ failure, all that sort of stuff within a region. But if that region goes down, that region's down. And that's a design decision that we've made. Now, in the future, can that change? Absolutely. This is another key thing, because even if the data center is down, that doesn't mean the service is down. Because we forward deployed a lot of this logic and a lot of this processing to edge, where we can actually eventually have a lot of slimmed down versions of these instances and services running, if our backend goes down, for let's just say 5 minutes, people might not even notice, right? And so that's where I think you have to plan for what needs high availability, what needs disaster recovery. Personally, I think for a lot of new services, we don't have any disaster recovery in mind. We want the service to be highly available, plan for that, and in the very, very small niche case, it is what it is. So, go ahead.
So, by the way you've been describing things, I want to assume you guys are using a microservice architecture.
Yep.
For your company, do you guys use just a single database with the vector database, or do you guys use multiple databases for each specific service?
Yeah, so today it is consolidated. Whether or not it does go to specialized, I mean, it will depend. But I think, it really kind of comes down to, a few things, right? So there's the embedding piece. So how do I translate from text into my vector? And then there's the actual vector piece. When we think about kind of what we built in the backend, right? We have all this business data, all this customer data, all this developer data. And there's a lot of benefit by having everything kind of together. Now, the one thing is you can have specialization where what you may do is you may look up a vector in one and a vector in another, and then correlate those two together. But for now, it is all converged. Whether or not it does move to specialized, that's something that we'll have to look at, yeah. Because the question is scale, right? So if you have everything in one thing, can it scale? I mean, that's to be determined, so yeah.
Yeah. So you described multi-tenancy multiple times. Can you describe what it is and how you are designing for that?
Yeah, no, as an example, so multi-tenancy, right? So when we think about, let's just say, we have customer 1, customer 2, customer 3, right? Now, I can either create one full service deployment for them, another for them, another for them. I can have a dedicated collection or a dedicated cluster for them. But the thing is it doesn't really scale efficiently, right? Because if I have 1 million customers, I have 1 million different instances or deployments. I have 1 million different collections or 1 million different clusters. And so the idea behind multi-tenancy is twofold. So what I was describing is physical multi-tenancy. So, it's actually physically separate. There's also the idea behind logical multi-tenancy. So logical multi-tenancy is I have one single thing, and then I put pieces or partitions for each one of those tenants. And so, if you look at kind of a collection, so let's just say I wanted to build that as a collection. I could do that via a collection. But the thing is it still doesn't scale, right? Because 1 million customers, 1 million collections, and then also all those customers have the same structures and things. And so what we did is in every document structure, we essentially have a tenant key. And then that tenant key is what we use to actually segment or scope data. So when customer 1 logs in, and let's just say they want to do a list or a find, automatically and enforced is that their tenant key is automatically added to that find. And so they only get results specific to them. And this is important because not only from a MongoDB perspective, but also on the vector database side of things as well, is we can't build up 1 million vector databases, right? So everything is multi-tenant today. And so, enforcing that is very critical. One of the other aspects of that too is, authorization. So, in terms of multi-tenancy, obviously building it into the document structure gives us one thing, but in terms of authorizing who can access what, that's also a very important thing. So because we kind of designed authorization with multi-tenancy in our object model together, we ensure that when things are authorized, it's always authorized against that tenant key. And then even within a subset or scope of documents, we can authorize a specific actor. So basically, the key benefit that multi-tenancy gives us, building it into the document structure, is we minimize the number of our deployments. We minimize the lifecycle and management overhead of those. And also, it enforces data security because if you have physical security or physical isolation or physical multi-tenancy, people people get lazy. They're like, oh, this is only for this tenant. I can access whatever. But in reality, that's not always the case. And so this allows us to, and enforces us to always be very, very cognizant and very, very assertive that things are always done on a per tenant basis. And so even, let's just say, from an AI model or an AI service perspective, when it's actually looking up documents to leverage for RAG, it is all done in the context of a tenant, right? So when it goes from that embedding to the vector and fetches those documents are only specific to that tenant when we return them. And so, basically, multi-tenancy is one core thing, but building it into the data actually gives you a lot of benefits because as that data moves or as that data migrates, I know exactly who that belongs to. And so if it moves from one system to another system to another system, to even like our data warehouse analytics side, that tenancy key is there. So all the way through the stack, it actually traverses as well. So that's a key thing.
Awesome. Thank you so much, Steve.
All right, cool. Thank you all.